Nandini, all set?
हाँ all set. Good afternoon, everyone. Can we just make sure that I'm audible to you all? Am I audible? Okay, so firstly, I'd like to welcome you all to the Machine Learning Marathon, Day 1 Introduction to Machine Learning by GDSC ADGIPS. I am your speaker, Nandini Singh, the AIML lead at GDSC ADGIPS, and currently I'm working as a machine learning intern at Reliance Geo. So, today we'll be discussing mostly the theory part of the machine learning marathon. So, here we'll be discussing about AI, deep learning, what is machine learning, its various types, and some of its examples. We'll also be going over the machine learning process flow and the various challenges that we face in the machine learning world. So, day two would be more focused on the practical and hands on machine learning. So, let's start with day one introduction to machine learning. So, have you guys heard about the humanoid Sophia? Or if not Sophia, you guys must have heard about Tesla, right? The self driving car. We all have heard about it. So, have you guys ever thought about how Instagram is recommending you posts which are actually very similar to the posts that you have already interacted with? Or have you ever thought how YouTube or Netflix are showing you content which is very similar to the content that you have already watched? So all of this is using machine learning in the background. Now to understand what machine learning is, we first need to go over the buzzwords in the modern tech industry. So they are artificial intelligence, machine learning, and deep learning. Now, as you can see from the Venn diagram here, artificial intelligence is like this superset. It is containing machine learning, and machine learning in turn is containing deep learning inside it. So, what is artificial intelligence? So, when we talk about artificial intelligence, it is the science of actually training systems which have human like intelligence. So, you are incorporating human like intelligence into systems and machines. So, that is artificial intelligence. Then we have machine learning, which is a subset of artificial intelligence. Now, what is machine learning? It is the science of training algorithms and training systems which learn from their previous experiences. You are not explicitly programming the machines to perform something, they are using their past experience to actually learn from their experience. And then we have deep learning, which is a special type of machine learning in which you are training models which mimic the human decision making and the human neural system. So that is deep learning. Now, what is data science? Data science is the intersection of artificial intelligence with maths and statistics. So that is data science. Now that we have discovered what's AI, ML, and DL, let's move on to what is machine learning in depth. Now, what is machine learning? So, as we discussed earlier, machine learning is a subset of artificial intelligence in which we are training models or machines to learn from their previous experiences over time. So they are learning to perform a specific task based on how they have performed the task in the past. So that is learning from their experience and actually improving their performance over time. So you're not explicitly programming or writing a program that you have to do this, you have to do this. They are learning it from their experience. Now, machine learning can be broadly categorized into three types. So we have supervised machine learning, unsupervised machine learning, and reinforcement learning. There's also one more type which is semi-supervised learning. We'll also go over that. So let's start with what is supervised learning. So supervised learning, as the name suggests, has some kind of supervision in that. So supervised machine learning is the type of machine learning in which you are training models on label data sets. So you have input data variables and then you also have the output labels for that. So as you can see from the diagram below, we have shapes and we also have the labels of the shapes. So for example, we have rectangles, circle, triangle. So we have the data as well as the output labels which can be given to that data. So you feed this data to the machine and it learns the relationships between the input variable and the labels associated with that. So when once you have trained the model, if you give it the shape, then it's going to predict whether it's a triangle or a circle. It's going to predict the label which is associated with that shape. So this is supervised machine learning. Now supervised machine learning can be broadly divided into two types. So we have classification and regression. Now what is classification? So in classification, you are predicting a categorical variable. So as we discussed in the previous example, we were finding out if it's a triangle or a circle. So that is predicting a category label or a class for a given data set or data item. Okay, so for example, and more examples can be spam detection. So for example, you get a lot of emails. So detecting whether it's a spam email or a non-spam email. We talked about image classification. So that would be classification because you are predicting a class or a category label. Then we have regression. Now, what is regression? In regression, you are trying to predict a continuous numerical variable. So, for example, the very common example we have is house price prediction. So, you are predicting the price of a house, apartment, on the basis of various features like its location or the number of rooms it is having, so features like that. So that would be regression. And more examples can be, for example, if you have to predict my weight on the basis of like various features, my age and everything. So that would be regression. Now let's move on to unsupervised machine learning. Now unsupervised machine learning is a type of machine learning in which you are training models on unlabeled data. So you are just giving the data items. You are not giving any label which is associated with that. So in this, the model has to find out any patterns or structures, the relationship between these data items so that they can be grouped together. So for example, here we have a lot of animals, we have elephants and everything. So in this, you're not giving it any label. It is just finding out what data items are similar to each other and then grouping them. So it is called unsupervised machine learning because there's no supervision. You're not actually giving it any label. It's doing the work by itself. You're just giving the data items and it is finding out the similarities or any meaningful insights from that data. So that is unsupervised learning. Now it can be divided into many types. So first we have clustering, like we just talked about. Clustering means finding clusters or groups of data. So you're grouping similar items together. So that is clustering. Then we have, now let's talk about the difference between clustering and classification because many people confuse the two. Now clustering is finding groups of data items which are similar to each other, whereas classification is you have been given a data item and then you have to classify it, keep which category or which class is it belonging to. So that is the difference between clustering and classification. Then we have association. Association basically means finding out which data items are going together. Like for example, if I'm buying bread, then I might buy butter as well. So these two are going together. So you are finding frequent data items which are going in together, which are like existing together most of the time. So that is association. And then we have anomaly detection. Now, what is an anomaly? Anomaly basically means something which is very different from the normal or like the other data items. So that is anomaly detection. Now, anomaly detection can be like finding outliers. Now, you might ask, what is an outlier? So, an outlier is a data item which is existing very far away from the normal data item. So, we have, for example, if I am making transactions of like 100 rupees, max 1000 rupees, and then someone uses my account to make a transaction of like 10,000 or lakhs, so that would be an anomaly because or an outlier because I don't do transactions which are higher than huge amount of data. We can't let that go to waste, right? So that's why we use unsupervised learning as well, so that we can make use of that unlabeled data as well. So this is supervised machine, semi-supervised machine learning. Now let's move on to reinforcement learning. Now reinforcement learning is a type of machine learning in which the agent or the robot is trying to learn to make decisions on the basis of the environmental factors. So for example, a very simple example, if I'm studying in my room and I'm using my phone when I'm supposed to study, and my mom is in the other room and I hear her coming, so what would be my decision? It can either be to keep my phone away and start studying, or it can be to continue using my phone. Now, what would happen to this? If I don't keep my phone away and I continue using it, then I'll get a negative feedback. So that I know I don't have to do this in the future. Now, if I keep my phone away, then when my mother sees me studying, then she'll obviously give me a positive feedback, right? So I know that this is what I'm supposed to do. So in reinforcement learning, you are using this feedback loop. You have an agent who is observing the environment and taking some action, and then it's given a reward or a penalty. So it learns that, do I have to do this in the future as well, or do I have to stop right now? So that is reinforcement learning. Reinforcement learning is very heavily used in the real world scenarios, for example, in game playing and robotics. Like we talked about Sophia, right? It is a robot which is exactly like humans. So it has to understand its surrounding and then make sure that the actions it's performing are right. So it has to learn through the environment. So that is in robotics. And then we talked about Tesla, autonomous vehicle. So in a vehicle, when you're driving, what's the most basic thing you have to do? You have to learn from the environment, right? You have to observe the environment and make sure that you're making the right decision. That's why we use reinforcement learning. And then we have recommendation systems. So for example, if I am on an e-commerce website and I'm looking for electronics, then the environment is that I'm looking for electronics. So the e-commerce website or the model is going to recommend me products which are electronics. Now, if I shift to dresses, then the environment would be that I am in an environment where I'm searching for dresses. So that would be a recommendation system for dresses. So the machine learning model will see that I'm in an environment where I'm searching for dresses. So that would recommend me dresses. So this is reinforcement learning. Now, let's move on to the machine learning process flow. Once we have covered what are the types of machine learnings, let's move on to how we actually train a model. So the checkpoints while training a machine learning model and deploying it are data collection, data preparation, choosing and training the model, model optimization, model evaluation, and model deployment. Now, let's talk about each one of them in detail. So, what is data collection? So, in data collection, once you have understood what is the problem you're trying to solve, you'll find out what kind of data you need. So, maybe you're looking through Kaggle and government websites, or maybe you're conducting surveys, questionnaires to actually collect the data. So, that is data collection. And then we have data preparation. So, many of the times, the data that you have collected is not in accordance to how you would actually use it to train a model. So, that would be data preparation, that you have to prepare it in order to convert it into a format which is suitable to your use. Then we have choosing and training the model. Once you have understood what the problem is, what you're trying to solve, then you have collected the data, you have processed it, then what you can do is you have to find out what kind of algorithm that you want to use for this. So that would be choosing and then training the model. Once you have trained the model, you have to make sure that it's performing well. So you test its accuracy, precision, and everything. So that would be model optimization. You are actually optimizing it to perform better. Then you have model evaluation. So before deploying a model to production, you have to make sure that it's doing well so that the public actually likes your product, right? So that would be evaluate your model, how it's doing. And then once it is above a certain threshold, then you can deploy the model to production. Now, these are the steps involved. As we discussed, we have problem definition. So clearly understand the type of problem you have and the objective, like what are your stakeholder expectations. So you understand what you are trying to do. Then we have data collection and preparation, data splitting. Data splitting means breaking down your data set into three main portions, let's say. So we have training, validation, and testing sets, so that you can actually use some of the data to train your model and then to check it during training if it's doing well, and then the final model, which can be we can check its accuracy with the help of testing sets. Then we have feature engineering. Now, what does feature engineering mean? Feature engineering means that you have a lot of features in your data set. You have to find out the features which are the most important. So you can either drop some of the features, and you can make one feature out of three features. So that would be feature engineering. Then we have model selection, training, evaluation, that we already talked about, and iteration and improve. It basically means you have to check the model again and again if it's doing well or not. Then we have deployment, and after deployment, you have to constantly monitor and maintain the model so that it's in accordance to what the public or the general needs are in that specific time. So that is the monitoring and maintenance portion. And then we have the challenges in machine learning. So in the tech industry, you run into a lot of challenges, and especially when you are in the machine learning industry, there might be a lot of challenges you face when you are training a machine learning model. So what are the challenges? The first is data quality. Now we have a lot of data available. We have huge amount of data available, but it's not good quality data. It's not in accordance to what or how you can use your data to actually train your model. So data quality is a very important factor when you are training a machine learning model. So let's say if you have bad vegetables and you're trying to cook a meal, the meal is going to be bad, right? So it's the same. You need good data for a good model. So that is data quality. Then we have data privacy and security. When we are training machine learning models and we are using sensitive data, for example, if you're using healthcare or finance data, so that needs to be protected to make sure there are no breaches and everything. So that's why data privacy and security are very important to maintain. Then we have overfitting and underfitting. Now, what does overfitting means? Overfitting means when you are training a model which is doing very well on the training set, but it's not actually doing well on the test set. So that is overfitting. And then we have underfitting when the model is actually not capturing any of the relationships. Like even in the training sets, it's not capturing the relationships, so they're not performing well. So you need to make sure that your model is not overfitting or underfitting. And then we have resource intensiveness. Now if you're a student and you're not working in like a big immense, you're like big firms, then you don't have that much resources. Now you might have heard key machine learning models require GPUs and everything. That's why we are using collab and everything, right? So machine learning field is very resource intensive. If you're training models which are very huge and you want the models to like do big tasks and like efficient tasks, then you need a lot of resources. So with this, we have covered the theory portion for machine learning, introduction to machine learning. We have covered what is AI, ML, data science, deep learning. We have covered the types of machine learning and its various examples. And we went over the machine learning process flow and also the challenges. So with that, I'd like to end with the day one of introduction to machine learning. Now, if you have any questions, you can drop them in the comments. I'd be happy to answer. Um, are there no questions? Okay, so I see Chaitanya is asking that he couldn't hear the semi-supervised part. So let's do a revision of the semi-supervised machine learning. So in semi-supervised machine learning, what you're doing is you are using machine learning, like supervised machine learning as well as unsupervised machine learning. So in supervised machine learning, what do? We use label data set. So you have the input data as well as the label that is associated with it. And in unsupervised machine learning, you just have the data items. You don't have any label associated with them. So in semi-supervised machine learning, you are using a data set which is partially labeled. So let's say 20% of the data is labeled and the 80% is unlabeled. Now, why do we use semi-supervised machine learning because we are trying to make use of both the advantages of supervised as well as unsupervised. In supervised, you have labeled data, so it's a small amount of data, but you can make good use of it because it's labeled. And then a lot of the data, we have abundant of data which is unlabeled. We can't let that data go to waste, right? So we are using unsupervised machine learning to make use and find out insights from that unlabeled data as well, because we have a huge ton of unlabeled data. We can't just let it go to waste. So that's why we use semi-supervised machine learning. Yes, so that is semi-supervised machine learning. Do we have any other doubts? Okay, so any specific course or YouTube video to follow? So I personally followed the machine learning specialization course by Andrew NG. He's like the ML god. You can learn everything from him. Okay, so that is a course which I would personally recommend. It's by Stanford Deep Learning AI, and we have the instructor Andrew NG. Huge respect to him, such a great teacher. So that is the course that I would recommend. On YouTube, we have Krish Nayak and also Code Basics. They are like very great. You can have them in Hindi as well, in English as well. So I recommend these two. Any more questions? Yes, Krishna has also started his Hindi ML playlist, so you can also follow that. He's a great teacher. I've learned a lot from him, and I still do. I still refer to their videos. So I think with that, we'll conclude the day one of the machine learning marathon. Today, we went over mostly the theory part. So tomorrow, at the same time, we'll be focusing more. Tomorrow's session would be focusing mainly on like the hands-on part, the coding practical part. So tomorrow we'll be doing that, and we'll see you at the same time, 4 p.m. tomorrow evening. So I hope you guys learned something, and it was a easy session. It was an easy session, and you guys learned something. So thank you so much for joining in, and I hope to see you all tomorrow. Thank you. Yes.